Okay, so the hydrogen bonds are stretched out. Okay, and when they're stretched out, what happens if you look at these pictures, right? There are more water molecules in this space over here when it's liquid than there are over here when it's solid, right? So if you counted all the red dots here, you would have more than you have over here. So that contributes to the density. So ice is less dense than water. Okay, so a chunk of ice has fewer water molecules than an equal volume of water. So it floats. Okay, and when we solidify it, right, the water molecules aren't moving as much and the bonds like stretch out. Okay, so you could even think about when you fill the ice cube tray and you put water in the ice cube tray and you let it get solid and the ice comes over the top. Okay, so if ice didn't float, okay, the stuff underneath of it would freeze. Okay, so the layer of ice on the top of things like ponds or oceans, it actually provides a layer of insulation. So it keeps what's underneath from freezing solid. So the penguins might die if there wasn't ice on the top of it. Okay, now solvents. So remember, you should know this vocabulary. Okay, so a solvent is something that does the dissolving. Okay, a solute is something that gets dissolved. Okay, like in this picture, I guess it could be salt water. Okay, so they're adding salt to the water. Okay, so the solvent is the water, the solute is what is being dissolved, and then it's going to form a solution. Okay, so those are important vocabulary words. Okay, water is the most biologically important solvent. Okay, so we're composed primarily of water. Okay, so um, the way water is organized with those hydrogen bonds, they are actually, it takes a lot of energy to change water from a liquid form to gas. Okay, so liquid water can absorb and store large amounts of heat and the temperature doesn't change. So water is really good at moderating temperature. Okay, so for us, um, it means that the temperatures on our planet are very stable because we're like mainly, the earth is mainly water. So it just takes a lot of energy to change water to get rid of it. So like you could think about microwaving water. So if you did a little thing and you put a cup of milk in the microwave and a mug of water in the microwave, right? 2 different times. And you microwave them for the same amount of time. Like if you put them in there for 2 minutes, the milk would boil over, right? But the water might just start being ready to boil. So it takes more energy to change water to a gas or to heat up a amount of water. Okay, we use evaporative cooling and sweating, okay, to regulate our temperature. So it takes a whole bunch of energy or heat, and that'll kind of it'll pull the water off of us. Okay, so evaporative cooling is one way that living things can use water to regulate our temperature. So whenever we sweat, okay, we have the water on the surface and that's gonna like take heat away from us. It's gonna cool us. And like a swamp cooler or something like that. It's the idea that it takes a lot of energy, so it's gonna remove heat. Oops, hold on, I'm trying to clear this. Clear, oh, clear my drawing. Okay, now water, because it's polar, also causes water molecules to stick together. So we have cohesion and adhesion. So cohesion is when the molecules stick together. Adhesion is when they stick to something else. Okay, so cohesion, they're sticking together. So when water is like the water molecules in a pond or something, they're totally going to stick together. And this one, they have a spider on top of it. But I always think about like a water skipper that's sitting on the surface. Okay, so it's because of the surface tension of water. Another thing is if you think about if you have a drop of water on the surface somewhere, it's shaped like a drop like this, and it's going to take a long time for it to evaporate. Whereas if you have a drop of alcohol, it spreads out like this. It doesn't have as many hydrogen bonds. It's not the same, right? So then it evaporates more quickly, and you can't really sit anything on it. We need to talk about pH. Okay, so pH is we have to. I would just want to talk about, and we can go back and talk about how it affects things. Okay, so most everything that happens in life is going to occur in water. Okay, and the aqueous solution is a substance that's dissolved in water, right? So you think aqua, Aquaman, water. Okay, now in any aqueous solution, some water molecules are going to break apart, and we're going to have hydrogen ions, which are just the H plus, and hydroxide ions, which are OH negative. Okay, the concentration of hydrogen's ions in a solution determines its pH. So we go here, and your book has it going a different direction, but it's the same thing. Okay, so the pH scale is how we measure pH. Okay, so on here we have 0 and we have 14. Okay, so 7 is neutral. Okay, so 0 to 14, 7 is neutral. From 0 to 7 is acidic. And then from 7 to 14 is basic. Okay, each time the number changes, that is a tenfold increase or a tenfold change in the number of hydrogen ions that you have. So something that is up here has less hydrogen ions than something that is very acidic. It has more hydrogen ions. Okay, so remember A and B. And if you go from 0 to 14, acid is before base, and it's in alphabetical order. Okay, now this is saying, okay, so acids have a pH between 0 and 7. There's some things on here you can look at it and recognize. Okay, so like lemon juice, battery acid. Our stomach is about a 2. Okay, base removes hydrogen ions. Okay, so it's between 7 and 14. And you guys can you can read that and see what they're talking about. Okay, now buffers are important in our body. So buffers are going to regulate pH. So what they're going to do is they're going to kind of minimize the changes in pH. So they're going to keep it stable. So normally in our body, whenever we're doing stuff, just the process of living, we're going to become more acidic. Okay, so everything that we do creates hydrogen ions and we become more acidic. But we have all these buffers in our body. We have different buffering systems, and that keeps us neutral, keeps us relatively neutral. So you can also think about this like if you have like buffered aspirin. So some people take aspirin for like for heart disease or to prevent heart disease, and the aspirin that they take is buffered, or you might have heard of bufferin, or they call it enteric aspirin. It's coated with a buffer. because aspirin is acidic. So we don't want to add more acid to your system and cause you to have heartburn. So how does pH, if the carbon dioxide is directly correlated to hydrogen ion concentration. So as carbon dioxide concentration goes up, hydrogen ion go up, things become more acidic. Okay, so things become more acidic, and that affects life. It affects how things can function. It's not good if things become more acidic. So we have things like acid rain. So every time we add acid to something and we can't get it to go back to normal, it causes problems in how living organisms can function. Um, yeah, you guys can read that. It's one of those think, pair, shares. So we're gonna keep going. Okay, so now I'm gonna stop right here and then I'll make another video. Okay, so this is a good place to stop and save.